Differentiate the function f of x equals 1 divided by x using first principles. So we know that the derivative f dashed of x is given by the limit as h approaches 0 of the function evaluated at x plus h minus the function evaluated at x all divided by h. So that's the definition of differentiating using first principles. Therefore, for this particular rule, f dashed of x will equal the limit as h approaches 0, and we need to remember to write that on every line of our working, of f of x plus h, which is simply 1 divided by x plus h, minus f of x, which is simply 1 on x, all divided by h. So in order to simplify this, we're going to need a common denominator for the fractions in our numerator. So we're going to multiply this by x plus h over x plus h, and we're going to multiply this fraction by x divided by x. Therefore, f dashed of x, our derivative, is going to equal the limit as h approaches 0. And now instead of this divide by h all the way at the bottom, we're going to write that as 1 divided by h out the front. And then our top line, or our numerator, is going to be x over x times 1 over x plus h, which will give x divided by x plus h, minus x plus h all over x plus h when you do the multiplication of that second fraction. Simplifying this further, we'll have f dashed of x is equal to the limit as h approaches 0, and then we'll have our 1 divided by h multiplied by, and the top line will be x, and then it'll be minus x minus h when you distribute that negative through, and then the common denominator is simply going to be x squared plus xh. At this point, we can see all the terms in the numerator not involving h will cancel, because this x and this negative x will cancel. And in addition to that, we'll have this h on the numerator and this h down here as being able to cancel. Therefore, our derivative f dashed of x is going to equal the limit as h approaches 0 of negative 1 divided by x squared plus xh. And now we can evaluate this limit by substituting h equals 0 into this fraction, and that is going to equal negative 1 divided by x squared plus 0, which is just x squared. Therefore, we find that f dashed of x, the derivative of f of x, is equal to 1 divided by x squared for this question.